Whether you're looking for answers to specific life questions or simply hoping to become the best version of you possible, welcome to the Mental Breakdown and Psychreg podcast, where we offer insight, information, and strategies based upon research and years of practice as psychologists. So sit back, have a listen, and get connected with our hosts, Dr. Berney and Dr. Richard Marshall. Welcome back. Today is the day we're going to talk about some of the biological bases for depression. Now, as we said on Monday, some depression has, identifiable or recognizable biological roots.
Right.
And we're going to talk about some of that. Others don't. So we do work sometimes to differentiate between biological depression and environmental or sort of social stressors or environmental stressor related depression, which we'll talk about tomorrow.
Right.
But today we're going to talk about biological piece.
Right. And all week we've been talking about the complexity of depressed complex disorder. In fact, I have to mention the National, Neurological Diseases and Stroke, I think that branch of NIH did a huge paper a year or so ago about, I'll have to get it, maybe we'll post it on Saturday, about how complex, it's the symptom complex of depression. So we have to get that to viewers. It's a very, very long technical paper, but it's really a good thing to add. So we talk about the complexity, and what we don't want to do is get hung up on what has now become a figure of speech, that that depression is this chemical imbalance, that somehow it might be.
Yeah.
But it's much more than that. Has many other things to consider besides the chemical imbalance hypothesis. That said, today we are going to talk about the biology of depression, and not because it's the most important, but because but it is important, because whatever's going on and whatever's causing depression, in one way or another, is going to involve the brain, whether it's triggered by something else or the brain is triggering it. We talk about internal or external causes.
Right.
The brain is going to be affected.
Absolutely.
So it is important, but remember that depression is more than just a chemical imbalance.
Right.
Okay.
Right. And also that the more chronic the depressed state is, the more your brain is going to be in that mode, if we want to talk about it that way, it's going to want to stay in that mode.
That's right. Because even if it's an external cause, it's still coming into your brain, and your brain is trying to sort it out. Right. Or it may be that, when you wake up and just feel blah that day, that's something going on in your brain.
Right.
That nothing has happened yet to change your day, so it probably has something to do with your brain.
And I think that this is where we get into some of that fake it till you make it, because your brain is in this state, and sometimes you have to intentionally get your brain out of that state. And so fake it till you make it, try to do something. You may not have the energy to go out and do something, but go out and do something.
That's right.
In a way, that's part of that fake it till you make it.
Well, but there is that whole notion of the whole idea, and it's true, that you have to get moving and you have to go do things. You can't give in to these things. However, and so we're always talking about, I was using the term however, if you do slip into a depressive state, then go get some help. But initially I think it's, I was explaining to a young 20-ish, mid-20s person recently, that when you have these feelings of sadness and depression and anxiety and the different things that you experience on a daily or weekly basis, that's your body's way of saying, do something. That you have this, you're disconcerted or you're disquieted, or it's your body's way of saying you're dissatisfied, go do something else. And what I was talking to this person about was, don't resort to drugs.
Right.
Don't cover it up with drugs.
Right.
It's your body's way of saying you need to make a fundamental change.
Absolutely.
That changes your brain too.
Right.
Because once you start producing those chemicals, your brain changes.
Yeah.
So there's an argument to be made for get up and get going.
Yeah.
You don't have to fake it. Just get up and get going.
Right. Yeah. Absolutely. So this think about the biology. All right. There's 3 parts of biology that we want to talk about. Right. The first is physiology, the first is anatomy.
Yeah,
basically, the structure itself. Mm-hmm. And so, I think it's fascinating. I'm being careful. Because this is
watching him.
This is what you were alluding to
I said yesterday. This is what we have to be careful of today.
It's fascinating to me that anytime we talk about brain regions associated with a disorder or a condition or a disturbance, we almost always start with the limbic system.
As we should.
Love it.
However.
There's other things too. But.
There's always a battle between the limbic system and the cortex.
Right.
Okay. But yes, we begin with the cortex. That's where all of it is, down there in the limbic system.
Down in the limbic system.
Those little rat balls down there, they're just causing all kinds of trouble. It's where the gremlins live.
It is. But one of the things that has shown, somewhat, I wouldn't say reliably, because I don't want anyone to have the misunderstanding that you could do a functional MRI or a PET scan or something and see the way someone's hippocampus is behaving and say, oh, well, you know what, that person's depressed. Because it doesn't really work that way. That said, some studies have shown that people who are depressed tend to have a smaller hippocampus.
That's right.
Now, we see that in other disorders as well.
Right.
So, it may just be that having a smaller hippocampus puts you at risk for developing something. It could be depression, it could be ADHD, it could be lots of other things. But generally speaking, people who are depressed, in some research has shown a smaller hippocampus.
But we've said this before when we talk about neuroimaging. Mm-hmm. You don't go to get an fMRI or an MRI. Right. MRI is structural, fMRI is functional. You don't go get an MRI to see if your hippocampus is smaller.
Right.
What we're talking about is if you take a large group of people mm-hmm. who have symptoms of depression, and you take a large group of people who don't have those symptoms, what we find is that the hippocampus is a little bit smaller mm-hmm. in the people with depression. Yeah. So think about this for a moment. If I have a patient and I put that patient in a scanner today, mm-hmm. how do I know that her hippocampus is smaller?
Right.
If I've never measured it before. Now, if I measured it when she was 15 and I measured again at 25,
right.
But we don't screen people with MRIs as far as I know in this country, right?
No.
I mean,
be cool.
One guy did.
Yeah.
Yeah, in the 90s. He did his kids. He scanned them every year. And that's how we discovered that the brain changes. It was his research, and he got criticized for that, because using his kids as a subject. But it turned out to be valuable research.
Just have an MRI
because he measured them every year.
In your basement.
Yeah. Well, I was thinking of, typically we have baby pictures on the wall. And this guy had 12 brain pictures. Instead of school pictures, he had brain pictures.
This is in first grade.
That's what a brain looked like in first grade. And he took some heat for that, but it was one of the reasons that we discovered blossoming and pruning in teenagers. We didn't know that until he said, oh my gosh, there's this change that occurs. Mm-hmm. And we didn't know that change occurred because mm-hmm. nobody had ever looked at it before.
Right.
But so it provided valuable information. But where were we going with that? Oh, so we did it with soldiers too.
Yeah.
But you can't do an individual soldier. You mm-hmm. say, here's a group of men who were in Vietnam. Right. Here's a group of men who didn't go. And the men in Vietnam, their hippocampus was smaller. Right. Shouldn't have been, but it was.
Right.
So they attributed it to the emotions that they experienced.
Right. And so that is how to answer the question that you asked. How do you know that it's smaller if you didn't measure it before? It's you take a whole bunch of people who were depressed
right.
and a whole bunch of people who weren't depressed, and you
right.
compare the average size of their hippocampus. Right. And people who were depressed, on average, have a smaller hippocampus than those that.
But you can't use that for a single individual.
Right.
It just doesn't work that way. So
right.
these are research tools.
Right.
Most of these are research tools. They're
Absolutely.
They're not clinical tools. It's not like an X-ray and you have a broken bone.
Right.
These are research tools that test groups of people
to
come up with differences. But we know that the hippocampus is smaller in people with depression.
Right.
Now let's talk about the chicken and the egg.
Well,
do they have a smaller hippocampus?
Right.
Are they depressed because they have a smaller hippocampus? Or do they have a smaller hippocampus because they're depressed?
Yeah.
And we don't know the answer to that question.
Right. Mm-hmm. Yeah. And if we ever do a week on schizophrenia,
yeah,
it's the same thing with them.
Same problem.
Except its overall brain density.
Right.
You know, how do we know? And I think that another twist to this that I would love to see them someone do some research on is what effect does the medication have on the size of the hippocampus? Because that's, again, something that's coming out of the schizophrenia research is that, well, you know, people with schizophrenia tend to have less volume in their, less brain volume, basically. But they don't know if it's because of schizophrenia, if the smaller brain volume density was there first, if they developed schizophrenia and that caused smaller brain density, or if the medication affected brain density.
Right. So, and
the
we
same
have
thing
all
with
the
depression.
same questions with depression. So there, we don't have. That's why we talk about depression as being a very complex disorder, because we kind of know some of these things, but we don't know why, and we don't know which comes first. So that's what makes this so challenging. Why it's such a complex disorder. Another
area of the brain right there, part of the limbic system as well, that's affected by in depression, or seems to be different in people who are depressed versus those who aren't, is the activity of the amygdala. And the amygdala butts up right against the hippocampus. So those who are depressed tend to have increased activity in the amygdala, which is all about emotions, which makes sense.
And fear and anxiety. And we talk about fear and guilt and all those emotions with depression. So is it the amygdala causing it? Might be. We don't know.
So that entire system there, the amygdala, and you mentioned the cortex. You know, the limbic system is all about sort of those intrinsic drives, those underlying emotional regulation, emotions and general memory and all that kind of stuff. And all of that is regulated by the frontal lobes, which, you know, the frontal lobe really is the majority of your cortex.
And the frontal lobe inhibits those. So if you think, not to oversimplify it, but if you think of the limbic system as producing emotions, and the cortex keeps those in check, it keeps them from getting out of hand. Otherwise, we'd be fighting and killing each other in the streets. It'd be like Gotham. Isn't that right? Gotham from Batman. Isn't that Gotham?
Great job.
Right?
That's good. Yeah.
See? I'm so proud.
It would be like Gotham.
Yeah. Because we would
Arkham Asylum,
or
more specifically.
What was that thing with Mad Max? Wasn't that another one where the things got out of hand because people
Look at you with the pop culture references.
Hey, I'm a hidden gem.
Who are you?
You went to the movie last night and didn't invite me.
I did go to the movies last night.
And you didn't invite me.
Avengers Infinity War is amazing.
And I found out about it.
I'm not going to say anything about it. You've been talking about it here in the office for
I didn't know you were. I did not know you were going to that movie last night. So we have these limbic structures, right? The amygdala, the hippocampus. And then we ask the cortex to control those emotions. There's always a battle between, I've been saying that in my workshops too. Most of these things are a battle between the limbic system and the cortex.
Yeah, absolutely.
Either there's too much emotion or not enough inhibition. And emotions,
mood-related issues, anxiety,
anger,
all of that stuff. It's the
Comes
same
right.
relationship. Yeah.
Right. And you ask your cortex, and we're going to get into that when we get into treatments, because some of the treatments increase inhibition and some of the treatments decrease the amount of emotion coming out of the limbic system.
Yeah.
So there's always this contest between these two.
Right.
Battle of the Titans.
Yes.
But man, that's 3 in a row.
Well, you said Battle
Bases
of the Titans.
are loaded.
You said Battle of the Titans. It's Clash of the Titans, but it's okay. It's close enough.
All right.
I'll give you credit for that.
Right. Bases are loaded, man. That's 3 for 3.
You're killing me, Smalls.
Oh man.
Do you know that one?
Oh.
Do you know it?
Yeah, but why?
I don't know why.
Smalls.
Sandlot.
Oh, no.
It's a
League of Their
baseball.
Own.
No. Sandlot. You've seen it, but probably a long time ago. I'm sorry, listeners and people watching. It's tough.
So the biological causes. I told you this was going to happen. Remember yesterday? I warned everybody yesterday. He's going to get out of hand. He's not going.
You started it.
No. The biological causes of depression. One is structural.
Mm-hmm.
A second is
chemical.
That's what everybody thinks it is.
Right.
Okay. But when we say, oh, SSRIs, it's a serotonin problem.
Right.
But what do we really know?
Not much.
Serotonin.
Norepinephrine. Dopamine. We could just keep going down the list.
Glutamate.
Mm-hmm. Which
GABA.
also means GABA. Yeah.
Right. GABA, glutamate, serotonin, dopamine, norepinephrine, acetylcholine.
Mm-hmm.
Okay. It might be chemical, but there are 5 or 6 or 7, I think they're up to 8 or 9, that we know of that are implicated in depression.
Right.
And when we talk about, and you say, okay, there are 7 chemicals. Let's just look at dopamine. There are 5 dopamine systems. Mm-hmm. There isn't just dopamine. There are 5 dopamine systems. So within each system, you could have multiple systems.
Right.
So even if it is a neurotransmitter problem, it's far more complex than we really understand today.
Right.
And we simply don't have the technology to say, this is what you need. You need acetylcholine. You need acetylcholine. I need serotonin. She needs dopamine.
Right.
We don't have that technology.
Right.
We give these medications and we look for a response.
Right.
Okay.
Yeah.
And that's as close as we can get. So even if it's a neurotransmitter, even if it is a chemical imbalance, it's still an incredibly complex undertaking.
Absolutely. And the last biological piece is the genetic piece.
Genetics.
And there is and this gets complicated, but there is an increased heritability rate.
That's right.
When there's a family history of depression.
Right.
They've done a pretty decent job of working to rule out environmental factors. Like if you're raised by a parent who's depressed, you're more likely to be depressed. Mm-hmm. Okay, that makes sense. And you might say, well, that's because of genes, or you might say because you observed a person who was depressed all the time, and you sort of modeled your mood after the person you observed. They've looked at some twin studies where they had twins who grew up in different homes, and that's sort of the best that we have because they share that genetic history, but not the environment.
That's right. And the twin studies are really, I think, the most informative because you have identical twins and fraternal twins. Mm-hmm. Identical twins, same egg. Mm-hmm. Fraternal twins, 2 different eggs. In the identical twins, if one has depression, there's a 60 to 80% chance that the other twin will have depression. Or as you said, twins who are raised apart, different environments. Mm-hmm. So it's not the environment that did it. Okay, but they have similar rates of depression. Right. But for fraternal twins, it's about a 10 to 20% chance.
It's about the same as if you just had a regular sibling.
Right. What would it be for any 2 siblings? So there is something is inherited. Okay. But again, we talk about genes. There are 9 candidate genes that they've identified so far that could be involved in depression. Okay. Mm-hmm. So even if it's genetics, it's not like some disorders like Huntington's or those kind of disorders where you have a single gene or a single chromosome. Here you're talking about 9 candidate genes, and we have to sift through all that. And this research is being conducted, but it's certainly not complete.
Right.
So even the genetic picture is very complicated. So once again, we return to Monday's theme. This is a very complex disorder, and it needs to be treated with carefully.
Yeah, yeah. Now tomorrow we're going to talk about environmental causes, which introduces a whole new set of complications. And so we'll enjoy that conversation.
We'll enjoy that one too.
Yeah.
I will.
So until next time, stay happy, stay healthy, and forget to be afraid. Thanks for sharing this episode of the Mental Breakdown and Psychreg podcast. Be sure to check out the show notes for links to follow us on Twitter and subscribe to our YouTube channel, where you will find all of our previous podcasts and much more. We'd be honored if you would become a patron through patreon.com, where any donation you can manage will go to the development and creation of more content. Just visit patreon.com/thementalbreakdown for more information. Thanks again for listening. Have an awesome day, and we look forward to being back in your feed tomorrow morning.